Then I am doing this video as part of my science one project. In this video we are going to solve the problem of double pendulum and find the equations of trajectory of theta 1 and theta 2 using Lagrangian mechanics. First we write the uh, positions of the bobs, both the bobs as a function of theta 1 and theta 2 by expressing their x coordinates and y coordinates as a function of theta 1 and theta 2. Next, we find out the kinetic energy as a function of theta 1 and theta 2, and even the potential energy. We find the difference between the kinetic energy and potential energy by subtracting them in order to substitute the quantity in the Lagrangian equation. These are the two Lagrangian equations for both the particles. We find out each quantity of the equation by substituting the Lagrangian which we have found previously and solve it. After finally finding out all the values, we get an equation of this form. In this, we take two new variables, alpha 1 of theta 1 and theta 2 and alpha 2 of theta 1 and theta 2, and f1 of theta 1 theta 2 and theta 1 dot and theta 2 dot, which represent the angular velocity, and f2 of theta 1 theta 2 and theta 1 dot and theta 2, which as the following, and substitute in the above Lagrangian equation. Now both the Lagrangian equations are converted into single matrix equation of this form. Now we find A inverse, which is adjoint of A by det A. As it is a 2D matrix, it is pretty obvious. Now solving that, we get this equation. These equations can be solved by Runge-Kutta method, which is a numerical method. Thank you. Hope you enjoyed the video.